Rotational Dynamics. Okay, the action of forces and torques on rigid bodies. Okay. So we have here the mass of most rigid bodies, such as a propeller or a wheel, is spread out and not concentrated at a single point. Now, these objects can move in a number of ways. So if we refer to figure 1, so this is one possibility called translational motion, wherein all points on the body travel on parallel paths, but not necessarily straight line. No? Basta parallel yung path nila. Now, in pure translation, there is no rotation of any line in the body because translational motion can occur along a curved line. It is often called curvilinear motion or simply linear motion. Now, another possibility is rotational motion, which may occur in combination with translational motion, as in the case for the somersaulting gymnast. Ito, no? Yan. So, may rotational dyan. Okay, in figure 2, this one, no? Ito, nasa baba na kasi. No? So, in figure 2 helps to explain the idea of a torque. When you push a door with a force F, as in figure A, no? Ito yung door. So, almost top view kasi to, kaya hindi nyo makikita yung door, no? So, makikita nyo thickness ng door, almost, no? So, top view to, pero kung front view, makikita nyo yung rectangular door. Okay? So, pinapakita kasi dito yung doorknob wherein you apply the force. So, ito yung knob. Itutulak natin para mabuksan. So, this is the direction of the force. Okay? And the door opens more quickly when the force is larger. Okay? So, this is the force and this is the hinge, no? Yung axis of rotation. So, pag binuksan mo dito, mabubuksan kagad natin. Okay? So, this is the axis of rotation. However, other things being equal, a large force generates a larger torque. However, the door does not open as quickly if you apply the same force at a point closer to the hinge, as in part B. Okay? So dito sa A, malaki yung torque. Okay? Kasi lalo kung malakas yung force. Now, halimbawa, dito nyo itry itulak yung door dito sa point na to, mahirap. Diba? Parang mahirap buksan. So as you move closer to the hinge or to the axis of rotation, the more it would be difficult to open the door. Okay? Kasi yung torque dito is already very small. Whereas here in A, the torque is large enough to open the door. Okay? Now, in part C, in figure C, if your push is directed nearly at the hinge, no, almost near the hinge, you will have a hard time opening the door at all because the torque is nearly zero. In summary, torque depends on the magnitude of the force, on the point where the force is applied relative to the axis of rotation, in this case, the hinge, and on the direction of the force. Okay? So the farther the force from the axis of rotation, the larger is the torque. And the nearer the force to the axis of rotation, the lesser is the torque. And when the force is almost passing through the axis of rotation, the torque is almost nearly equal to zero. Okay? So in this case, if you trace the line of action of the force, o dito, hanggang dito yung line of action niya. Okay? So So, kakaunti na yung lever arm. No? So, the torque is actually the product of the force and the perpendicular distance from the line of action of the force to the axis of rotation. Okay? Now, the lever arm, ito yung lever arm. No? Kung ito yung force, the lever arm is the width of the door. Okay? So, yung lever arm, or sometimes we call it moment arm, okay, is the perpendicular distance from the line of action of the force. This is the line of action of the force. So ito yung lever arm, naka-perpendicular siya sa force. Now, that perpendicular line or distance from the line of action of the force up to the axis of rotation is what we call the lever arm or the moment arm. Okay? So since torque is the product of the force and the lever arm, so my F times the distance, the width of the door, so meron siyang torque, malaki. Whereas, when you compare the torque produced by the force in figure B, so this is the force, so basically the same magnitude, assuming the same magnitude of the force, but the lever arm of this force is only this distance. Itong maiksing distance na to. So if we multiply F by this distance, maliit siya as compared to the product in A. Yung force, ito yung distance sa A. Lever arm. Okay? So dito maliit yung torque simply because the lever arm is too short. Dito naman sa A, the torque is large because the product of the force and this perpendicular distance or lever arm is greater. Now, pagdating naman dito, okay, we extend the force and then we drop a perpendicular line to the line of action of the force. So, kung nandito yung line of action ng force, then we drop a perpendicular line. So, ito lang yung distance niya, yung lever arm. So, very small, almost zero. Okay? So, the line of action, okay, so halimbawa dito sa figure 3, the drawing shows the line of action and the lever arm of the force, two concepts that are important in the definition of the torque. So the line of action is an extended line. So if we extend this force hanggang doon, no? So malapit na siya dito sa axis of rotation. Ito lang ang kanyang lever arm, no? Kung saan yung line of action. It must be perpendicular always to the line of action of the force. So the lever arm is the distance L between the line of action of the force, no? So line of action of the force and the axis of rotation, measured on a line that is perpendicular to both. Okay? So the torque is represented by the symbol tau, no? Ito yung Greek letter tau. Yung parang letter T din, no? And its magnitude is defined as the magnitude of the force times the lever arm, no? So that is the torque, no? It is always the product of the force times the lever arm. And the lever arm is always a perpendicular distance from the line of action of the force to the axis of rotation or the pivot point. Okay? So look at this, no? So ito yung line of action of the force. And this is the axis of rotation. So yung kanyang lever arm, this one, no? So look at the definition. It is always perpendicular to the line of action of the force bago mo siya makonsider na lever arm. Okay? Now what about this one? If this is the door, but your force is an inclined force, no? Halimbawa, ganito yung force mo ay dito mo tinutulak. Okay? Okay? So, pag ganito yung force mo, naka-incline, hindi natin pwedeng masabi na yung width ng door ay lever arm. Why? Because hindi siya naka 90 degrees. Tingnan mo dito. Acute angle lang to, di ba? So, the door, the width of the door cannot be considered as the lever arm. So, what are we going to do? We project the force, the line of action of the force. We extend that. So, did you see this dotted line? Itong blue. Okay? Then, from the line of action of the force at this particular point, we drop a line perpendicular to the line of action and then connecting the axis of rotation. Okay? So we connect the axis of rotation. So itong dotted line na brown is already at 90 degree with the line of action of the force. So therefore, itong line ng dotted line na brown is the lever arm. Okay? So yun yung kanyang lever arm at itong length na ito ng lever arm is to be multiplied by F to get the torque. Okay? So yun yung pagkakaiba ng letter A sa letter B. Sa letter A, ang lever arm is yung mismong width ng door. Pero sa B, hindi yung door. No? Okay? So, that is the line of action. Ito namang letter C. Okay? Look at the force. Kung ang force nyo ay coinciding the line of action of the width, no? Kung yung force nyo ay dumadaan sa width, it will definitely pass the axis of rotation. So kapag dumaan yung force sa axis of rotation, then wala siyang lever arm. Zero. Okay? So if the lever arm is zero, definitely there is no torque. Zero yung torque. Okay? So tandaan nyo, whenever the force passes through the axis of rotation or passes through the pivot point, the torque is zero. Okay? Kasi wala naman siyang lever arm. Now, if we go back, basta dumaan yung force sa axis of rotation, zero torque yan. Wala siyang lever arm. Wala siyang perpendicular distance from the line of action to the axis of rotation. Now, itong sa letter B, if we do not want to extend the line of action of the force to get the lever arm para makuha itong lever arm na L, okay, pwede rin yung force resolve natin into its components. Okay? So if this is the force, then ito yung y component niya, this one. Okay? A vertical force upward. At yung horizontal force niya ay papunta sa left. Okay? So as you notice, the horizontal force will pass through the pivot point. Di ba? Kasi if we resolve this, yung kanyang horizontal component or x component will definitely pass through the pivot point. So therefore, yung x component ng force doesn't have a torque. Okay? Kasi dumaan siya doon. Parang letter C. Now, the y component is this one. Itong vertical. Okay? So itong vertical, meron siyang lever arm. Actually, yung lever arm niya is the width of the door. Parang yung sa letter A. Yun yung kanyang lever arm. Okay? So you need to compute for the vertical component. Okay? And then multiply that by the lever arm, yung width of the door. But you need to compute for the y component. Okay? So you need to know the magnitude and you know at least the angle, kung anong angle to, para ma-compute natin yung y component. And whether we will be using the sine or the cosine function. So depende kung itong angle na to or this one. Okay? So let's go back to the definition of the torque. It is always the product of the force, the magnitude, multiplied by the lever arm. So this is equal to F times L. Okay? Where L is the lever arm. Now, torque is just like a vector. Torque is also a vector quantity, no? Meaning to say it must have a magnitude and direction. So yung magnitude niya, product of the force and lever arm. So Newton is the force, lever arm is meter. So Newton meter ang unit of torque. Okay? Now, if it already reaches thousands, then kilonewton meter. Okay? Now, in English units, it is pound force. Okay? So, pound force times feet, so pound foot. Okay? Or foot pounds, yung unit of torque. Or kilopound feet, kung thousands of feet na. Okay? Now let's have an agreement that about direction. No? So when the direction of the torque, since it is rotation, di ba? So if it is, or torque is considered positive when the force tends to produce a counterclockwise rotation. So yun yung positive natin. Okay? And of course, we have a negative torque when the force tends to produce a clockwise rotation about the axis. Okay? So yun lang, dalawa lang yung direction, clockwise or counterclockwise. And positive yung torque kapag counterclockwise. Okay, so itong unit na banggit ko na yung unit, so that is Newton meter. Let's have an example. Different lever arms, different torques. Okay, in figure 3, a force of magnitude 55 newtons. So this is the figure. Where is figure 3? Oh, the same figure. Ito, no? Yes, ito pa rin yung figure, no? Yung door, no? Na may force. Okay, in figure 3, the force with magnitude 55 newtons is applied to a door. However, the lever arms are different in 3 parts of the drawing. In letter A, the lever arm is 0.8 of a meter. Okay, so this one, the lever arm is 0.8. So that means to say, that is the width ng door, no? So yun yung width ng door, 0.8 meter sa A. Sa letter B naman, ang lever arm is 0.6. Okay, where is this? This one, no? Itong dotted na brown or red line ba yan? Okay, that is the lever arm, 0.6. A little bit shorter than A. Okay, and of course, sa letter C, 0. No? As I've said, 0 kasi yung force dumaan sa axis of rotation or pivot point. So 0 yung kanyang lever arm. Now find the torque in each case. Okay, find the torque if the force is 55 newtons and the lever arm is 0.8. So in letter A, torque is equal to F times L, product of the force times lever arm. So 55 newtons times 0.8. So that will give us 44 Newton meter. Positive. So, ibig sabihin, this is a counterclockwise direction. So, let's try. Okay, so kapag may in-apply tayong force dito na 55 newtons and this is 0.8 of a meter, so sa anong direction ng door makikita nyo kapag nandito yung force tinulak? Ano yung direction ng door? Ano yung rotation niya?
Counterclockwise.
Yes, counterclockwise, that's correct. So positive, no? Kasi pag tinulak mo to, gagalaw na yung door, di ba? Iikot ng pagana to. Okay? Counterclockwise. So that's why you have here, yan. So that's correct, no? Sa letter B, tingnan nyo yung letter B. Ito, no? Ito yung kanyang lever arm, 0.6. If this is the force, ano sa tingin nyo yung direction dito? Is it clockwise or counter? Ha? Kitang-kita ito, di ba? Pag tinulak mo to, so ano ng direction ng door?
Counter po.
Counterclockwise pa din.
Counter.
Counter pa rin, no? Counter. It is still counter. Kasi yung force nga pa punta dito. So the tendency of the door is to rotate counter. So it is still positive. Okay. Now sa letter C, the force is there but there is no lever arm, 0. So wala siyang torque, 0 Newton meter. Okay? So sabi dito, in parts A and B, the torques are positive since the forces tend to produce a counterclockwise rotation of the door. In part C, the line of action of F passes through the axis of rotation, which is the hinge. So therefore, the lever arm is 0 kasi dumaan nga siya ng axis of rotation. So wala siyang perpendicular distance. Okay? And the torque is 0. Okay, let's have the physics of the Achilles tendon. Okay. Okay, in figure A of this problem, shows the ankle joint. Okay, yung ankle joint and the Achilles tendon. Itong nasa back sa likod ng paa. That is the Achilles. Okay? Attached to the heel, no? So itong tendon naka-attach dito sa heel at point P. Okay? Now the tendon exerts a force F. Okay? With magnitude 720 newtons. As figure B indicates. Okay, so nandito yung force. Nakita niyo yung blue line na arrow, na may arrow. Okay? So that is the force exerted by the tendon. No? So halimbawa, yung magnitude daw nun is 720 newtons. Okay? Now, find the torque, meaning to say, solve for the magnitude and direction of this force about the ankle joint with respect to the joint. Ito, no? So ito yung joint, yung ankle, no? So pinapakuha sa atin yung torque nitong force, no? About this point, no? So kung itatrace natin, if this is the action of the force, itong blue line, then ito yung axis of rotation, the ankle joint. Then we drop a perpendicular from the line of action of the force connecting the ankle joint. That is the lever arm. Okay? So hindi naman siguro kayo malilito yung kung ano ibig sabihin ng lever arm. It is always perpendicular to the force, line of action of the force. Okay? Then from pag perpendicular na siya sa line of action, you connect that with the ankle joint. Okay? So that is at 90 degrees too. Okay? So the angle is given also 55 degrees. No, the angle of the lever arm with respect to the horizontal. So ibig sabihin, itong lever arm has 90 degrees, 55 degrees with respect to the horizontal line connecting point P and the ankle joint. Okay? So kung 55 to, definitely, ano itong sa force dito? What is this one? So you take a look at this. Kung 55 to, tapos right triangle siya dyan, di ba? So kung 55 to, ano to? How much is this? Di ba 90 degree triangle to, di ba? So may 90 ka na. So dapat yung sum nitong dalawa is 90 also. So if this is 55, what will be the other acute angle? How many degrees?
35 po, sir.
How much?
35
Ilan?
po, sir.
Okay, that is correct. 35. The two, di ba yung sa right triangle, may isa na tayong 90 degrees. Of course, the sum of the two acute angles must also be 90. They must be complementary. So 90 minus 55, kaya magiging 35 to. Itong angle ng F with respect to the horizontal. Okay? So that is 35. Now, it is also given that the distance between point P and the ankle joint, the horizontal distance, no, is 3.6 times 10 to the negative 2 meters. Or this is simply 0.036 meter. Okay? So masyadong maliit. Okay? So kaya in-express in terms of scientific notation. Okay, so that is 0.036 of a meter. Okay? So determine the torque, magnitude, and direction of this force about the ankle joint. So what is the torque produced by this Achilles tendon force with respect to the ankle joint? So ibig sabihin yung ankle joint, yun yung axis of rotation. Okay? So if this is the force, we drop a line perpendicular to the line of action of the force connecting the ankle joint. Now this dotted line, itong naka-red, that is the lever arm because it is at 90 degrees with the line of action of the force. Okay? So dito sa letter B, ang gagamitin nating lever arm itong red at hindi itong 3.6 times 10 to the negative 2. Hindi yan ang lever arm. Okay? It is just the distance between the 2 points. But the correct lever arm is itong shorter distance. Okay? So kung titingnan nyo sa right triangle, itong lever arm is one of the legs. And yung hypotenuse nitong maliit na right triangle, itong hypotenuse na ito yung 3.6 times 10 to the negative 2. Okay? So write all the given. So the force is given. Then the location of the force is 3.6 times 10 to the negative 2 meter away from point P. Okay. So parang mali itong state ng F. F is located 3.6 meters away from the ankle joint. It should be the ankle joint, not point P. Yung point P, doon nga nag-originate yung F. Okay? So this should be 3.6 times 10 to the negative 2 meter away from the ankle joint. No? Ayan. So required is, what is the requirement? The torque produced by this force about the ankle joint. So we have the force, no problem about that. But our problem is this, hindi natin alam itong lever arm na to, itong red. No? Okay? But as I've said, since 3.6 times 10 to the negative 2, which is the hypotenuse, is given, and one of the acute angles is also given, then we can find the lever arm. And the lever arm is what? Adjacent, di ba? Adjacent to the angle, so we make use of cosine function. So 3.6 times 10 to the negative 2 meter cosine 55. And that is already the lever arm. Okay? So 3.6 times 10 to the negative 2 times cosine 55. Di ba? In a right triangle, we can find one of the legs for as long as the hypotenuse and one of the included angles is present or are present. No? So, we are now ready to compute for the torque, product of the force times the lever arm. So the force is given to be 720 times 3.6 times 10 to the negative 2 cosine 55. Okay? So if you try to compute that, can you give me the correct figure up to 2 decimal place rounded off? Kasi yung 15 rounded na yan eh. I-round natin sa convention natin, 2 decimal point. Okay? 3.6. Okay, 55. Okay, what's the answer? Up to 2 decimal place, round it off. How much?
14.87 po, sir.
Okay, that's correct. 14.87. What's the unit?
Newton meter po.
Okay, Newton meter. Okay? So we cannot use kilonewton kasi hindi pa naman siya nagta-thousands. Okay? Okay, so that is the torque. What's the direction? O tingnan nyo. What is the direction of the torque if papunta rito yung force?
Clockwise po, sir.
Yes, so it should be negative, no? We should make or we should put a negative sign to denote a clockwise rotation. Di ba yun yung ano natin, convention? Pag counterclockwise, positive. But since kitang-kita naman sa figure na yung force ay magko-cause ng clockwise, so we should put negative. No? So negative 14.87 Newton meter. Okay? So ito siya. Now, what could be another solution to this? Halimbawa, I want to use 3.6 times 10 to the negative 2 meter. I want to use this distance as the lever arm. Anong gagawin ko? Okay? Ayokong gamitin lever arm yung dotted line na red. Gusto ko itong black, yung distance between the two black points. Yung 3.6 times 10 to the negative 2. Gusto kong gamitin na lever arm ito. So, ano yung gagawin ko para makuha ko uli yung 14.87 Newton meter?
Find the vertical component po, sir, ng force.
Yes, that's correct, no? You need to resolve the force into its components. Okay, excuse me for a while. So we resolve the force. Okay, so ito yung vertical component niya. You just draw a line from point P, then vertically up. Okay? So ito yung vertical component. Tapos yung x component niya, you just follow the black dotted line going to the right. So hanggang doon. No? Yun yung x component niya. Okay? So makikita nyo, the x component passes through the ankle joint, which is the pivot point. Diba? So yung x component na yon, walang torque. Okay? Ang magkakaroon ng torque will be the vertical component. Okay? At ang kanyang lever arm is, ito na, yung 3.6. Okay? So what is the vertical component of the force? Equal to. Kung ito ay 55, what is the angle of the force with respect to the vertical?
35 degrees po.
Ah? Ano yung angle ng force with respect to the y-axis? Itong angle na to.
35 degrees po.
55. Ito, 55 siya, no? Kasi 35, ito, no? Ito, yung nasa loob. Itong nasa labas, sabi ko ba, with respect to the vertical. So this should be the same as this one, no? Okay? Ito, kung, di ba ito yung vertical component niya? Ang tinatanong ko, ano yung angle ng force with respect to the vertical? 55 pa rin, di ba? Kasi 35 tong sa baba. So itong sa taas is 55. The same as this one. Di ba? So, kung 55 ito, and the vertical component is adjacent to 55, so that will be 720 cosine 55. Di ba? Will you try to compute that? 720 cosine 55 times 3.6 times 10 to the negative 2. What's the answer? $720 cosine 55 times 3.6 times 10 to the negative 2.
14.87 Newton
Okay, so the
meters.
same, di ba? So whether you resolve the force and find the component that is perpendicular to 3.6, okay? So yun, no? So yung challenge lang dito is i-compute nyo yung component ng force. Kung gusto nyo gamitin yung 3.6 as lever arm. Pero kung ayaw nyo gamitin yung 3.6, ibig sabihin, i-retain nyo yung force. 720 ang gagamitin nyo. Pero, kukunin nyo naman yung lever arm. Okay? Magko-compute kayo ng lever arm. Kung gusto nyo gamitin yung 720. Ngayon, kung gusto nyo namang gamitin na lever arm yung 3.6 times 10 to the negative 2, i-compute nyo yung vertical component ng force. Kasi siya yung magkukos ng torque. Okay? Siya yung magkukos ng torque. Okay, any other questions dito? Nakuha nyo na ba yung kung bakit kailangan i-resolve yung force? Kung gagamitin nating lever arm yung 3.6? Kasi yung vertical component niya, yun yung naka-perpendicular dito sa 3.6 or yung 3.6 times 10 to the negative 2, naka-perpendicular dun sa vertical component ng force. Okay? Okay, next. Rigid objects in equilibrium. Okay. A rigid body is in equilibrium if it has zero translational acceleration. So yun yung mga conditions for equilibrium. Summation of forces along the horizontal is zero. Likewise, ganun din sa y or along the vertical, zero din ang summation of forces. And another condition of equilibrium is summation of all torques must be equal to zero. Okay? Let's try this diving board. Okay. A woman whose weight is 530 newtons, this one, okay, is poised at the right end of a diving board with a length of 3.9. So, yung length nitong board, mula dito sa bolt, naka-bolt part, no? Hanggang dun sa dulo ng kinatatayuan ng woman, so that is 3.9 meters. Okay? Now, the board has negligible weight. So, meaning to say, we do not consider the weight of the board. We just ignore it. Okay? So, negligible weight. And also, the board is bolted. So, nakita niyo itong napakalaking bolt. Okay? So, the purpose of the bolt is to hold. Okay? To hold the board from moving in a clockwise direction. Okay? Kaya binolt siya. Kasi otherwise, kung walang bolt at nandito yung woman, ano sa tingin yung mangyayari? Parang siso ba gaya, nakita nyo? Yung siso may fulcrum sa gitna, di ba? So kung may weight dito at walang nag-hold dito, yung board will rotate in a clockwise direction kung walang bolt. Di ba? Kasi may weight doon sa kabila. So bababa dito, itong left tataas. So ganun ang mangyayari kung hindi siya naka-bolt. Okay? While being supported 1.4 meter away by a fulcrum. Okay? So, yung left end, naka-bolt. The board has negligible weight and is bolted down at the left end while being supported 1.4 meter away by a fulcrum. So, the distance between the bolt and the fulcrum is 1.4 meter. Okay? So therefore, if this is 1.4, and you know that it was also mentioned in the problem that the length of the board is 3.9, so alam nyo na kung ilan to, yung distance from the fulcrum up to the point where the woman stands. Di ba? Kung 3.9 tapos 1.4, so i-minus nyo yun, ito yung length niya. Okay, the difference. So it is 2.5. Okay? 2.5 from the fulcrum going to the right end. No? Okay, the problem is we need to find the forces F1 and F2 that the bolt and the fulcrum respectively exert on the board. So ano yung force ng bolt and fulcrum? F1 refers to the bolt and F2 refers to the fulcrum. Yung fulcrum, ano yung force ng fulcrum? It should be an upward force. 'Di ba? Kasi support siya. Parang may pinapasan siya, yung fulcrum, may dinadala siya, 'di ba? So upward siya. What about the bolt? What do you think? What is the direction of the force of the bolt? Kasi pinipigilan niya yung board. What's the direction? Yung force ng bolt.
Counter, sir.
Ah?
Counterclockwise.
No, yung ano lang,
Downward, sir.
yes, downward na ano, be specific. Yung fulcrum is vertically up. What about the bolt?
Vertically downward po.
Yes, vertically downward. So ganito yung kanyang free body diagram. Okay? So this is the free body diagram and this is how they look like. Okay? Ito yung weight of the woman is always, of course, the weight is always directed vertically downward, di ba? So ito siya pababa. Now the fulcrum being a support, it should be an upward force, F2. And the bolt, hinuhold niya yung board, so kaya pababa siya. Pinipigilan niya. No? Kasi kung wala yun, tataas to. Okay? So, ito yung free body diagram and ito yung distance between the bolt and the fulcrum, 1.4. And this is the total length of the board, 3.9 meters. So, we know this distance from the fulcrum up to the point where the woman stands. Diba? It's just the difference nitong dalawa. So, that is 2.5. 3.9 less 1.4. Okay, the requirements are for us to find the two forces. What are F1 and F2? Okay? Okay, so assuming that the board is in equilibrium, okay? So we can start summing up vertical forces. Summation of all the vertical forces must be equal to 0. Upward forces are regarded as positive and downward forces negative. Okay? So summation of all the vertical forces is equal to, starting with F1, negative F1 because it is vertically down, plus F2 because it is vertically up, kaya positive, minus W because it is downward. Okay? Equal to 0. So this is equation number 1. Okay? Now, if we are going to follow the given, this should be negative F1 plus F2 minus 530. Is it 530? Let's check. Yes, 530, no? So, negative F1 plus F2 minus 530 is equal to 0, equation number 1. We cannot solve yet this equation because we only have one equation and yet there are two unknowns, di ba? F1 and F2 are the unknowns and yet we only have one equation. So we cannot solve this, no? So there are two unknowns, there must also be two equations for us to solve the problem. Okay? So let that be equation number 1. And where can we get the other equation? Saan sa tingin nyo tayo kukuha ng another equation? We
Sa
cannot,
torque, sir.
yes, no, from the torque. We cannot sum up horizontal kasi wala naman tayong nakikitang horizontal, di ba? So we are left with no other choice but to sum up the torques. Okay? Summation, because that is also one of the equilibrium conditions. Ito, di ba? Summation of all torques must be 0. But before you start summing the torques, okay, you must decide on the pivot point, the reference point. Which are you going to make as a reference point? You have 3 choices. The bolt, the point where the woman stands, and the fulcrum. So may tatlong choice kayo before you start the torque equation. Okay? So anong gusto nyong maging um, axis of rotation or the pivot point? Okay? So halimbawa, fulcrum. Halimbawa, fulcrum. So ito yung pivot point natin. What can you say about the torque produced by F2? Anybody?
Zero.
Zero, sir.
Why zero?
Kasi wala yung zero yung length na
Lever arm, no? So wala siyang lever arm, no? And aside from that, ano yung sinabi ko kanina? Magsisiro ang torque if what? If, ano yung condition? Aside from wala siyang lever arm, ano pa yung sinabi ko kanina? Na zero torque if what? If the force what?
Dumaan po, sir, yung force sa axis.
Yes, exactly. No, if the force passes through the pivot point or passes through the reference point, wala siyang torque. Okay? So, if we make the fulcrum as the pivot point, F2 is 0. And dalawa lang ang magpo-produce ng torque. F1 and the weight of the woman. Okay? So let us sum up the torque with respect to the fulcrum. Summation of all the torques with respect to this. So meaning to say F2 is already disregarded. Do not include any more F2 kasi wala naman siyang torque. So ang my torque is F1 and W. Okay? So summation of all torques with respect to the fulcrum. So bear in mind our convention that clockwise torques are negative and counterclockwise torques are positive. So if we start with F1, that is what? Is it counter or clockwise? Tingnan nyo yung ikot. Kapag may force dito, ano yung ikot nung...
Counter po, sir.
Counter po.
Counterclockwise po.
Yes, counterclockwise. So, start now the equation. F1 times 1.4. Correct? Force times lever arm. So, F1 times 1.4. And what is the direction of the weight ng woman? Is it counter or clockwise?
Clockwise po.
Clockwise
Yeah.
po.
Yes, so it is negative. So summation of torque, so we start with F1. So F1 times 1.4 minus 530 times 2.5. Correct? Bakit minus 530 times 2.5? Why? The magnitude is 530. Ang lever arm niya is what? Ito kasi yung reference point natin, di ba? Eh, ang torque baga, force times lever arm. Negative because clockwise. So, our equation is now F1 times 1.4 minus 530 times 2.5 equal to 0. Equation number 2. Okay? Okay, will you compute that? I think equation number 2 is another equation and only one unknown, di ba? F1. So one unknown, one equation, you can solve for F1. What's the value of F1? F1 times 1.4 minus 530 times 2.5 equal to 0. Solve for F1. What is F1 equal to?
946.43 po.
Okay, that is correct. Okay? Did anybody, what about the others? Kuha nyo ba yun? Okay.
Yes.
So having found that F1, F2 can now be solved by using summation of vertical forces. I-substitute na ninyo rito yung F1 so that negative F1 plus F2 minus 530 is equal to 0. With this equation, only F2 is unknown, so you can solve for F2. Okay? I-transpose nyo yung weight. So F2 is equal to 530 plus F1. And what is F1? Dagdagan nyo lang ng 530. Kasi
One-
F2 is equal to 530.
1476.
How much? 1,000?
1,476.43 po.
Okay, 1,476. So 1.48 kilonewton. Okay? Kasi lumagpas na siya ng 1,000, so we can already use kilo, di ba? Okay, so that's correct. Oh, ito kasi naka-rounded na, no? But we follow our convention na up to 2 decimal place. Now, let us check if that is F2, no? Okay, so how do we check na tama yung F2? Okay, one way to check that is choose another pivot point. Kanina baga fulcrum, di ba? Halimbawa, gawin nating pivot point yung bolt, itong axis of rotation. So, kapag ginawa natin yung axis of rotation or the bolt, okay, location as the reference point, F1 naman yung walang torque. Correct? F1 naman yung walang torque kasi siya yung dumaan doon. And sino yung magkakaroon ng torque ngayon? Sa tingin nyo, sino? Kung magiging reference point natin is the left end. Sino ang magkukos ng torque? You see F1 0, di ba? What about sino ngayon yung magkakaroon ng torque?
Yung F2 po, tapos yung weight.
Yes, no? F2 and W, yun ang magkakaroon ng torque. So apply now the equation. Summation of torque with respect to the point where the bolt is located is equal to what is the effect of F2? Anong rotation niya?
Counter.
Is it, yes, counter. So that is positive. So, pwede tayong gumawa na ng equation. Summation of torque equal to 0. So let's start with F2 times 1.4. What about the weight? Anong direction niya?
Clockwise.
Yes, clockwise. So that is negative, di ba? So let's start again. F2 times 1.4 minus W times, this time, ang lever arm niya is 3.9. Hindi na 2.5. Okay? Remember, bago na yung axis of rotation natin. Nandito na. So the lever arm of the weight of the woman is the total length of the board. Okay? So I repeat, ang equation natin dito is F2 times 1.4 minus 530 times 3.9 is equal to 0. One equation, one unknown in F2, you can solve for F2. Give me the value of F2. F2 times 1.4 minus 530 times 3.9 equal to 0. Solve for F2. And compare the value of F2 with the value you obtained by summing up the vertical forces. How would you compare the values?
Same lang po, sir.
Okay, did you compute?
Yes po, sir.
Yes po, sir.
Okay, no? So, that proves na whether you choose any of the 3 points as the pivot point, you will arrive at the same answer. Now, what if I want the weight of the woman or where the woman stands as the fulcrum? Give me an equation for the torque. Summation of all the torques with respect to the point of the woman. So yung woman, yung weight, wala siyang torque kasi nandun siya, di ba? So ang may torque is F1 and F2. Now, give me the summation of torque equation. Well, you can start with the counterclockwise kasi positive siya. So sino sa dalawang force ang may counterclockwise? With respect to the right hand or the right end point.
F1 po, sir.
F1 po, sir.
Yes. What about F2?
Clockwise po.
Clockwise po.
Okay, i-dictate nyo nga sa akin yung equation ng torque with respect to the woman. Start with the positive torque. Sinong makakapag-dictate?
F1 times 3.9 meters
Okay.
minus F2 times 2.5 meters po. Equal 0.
Equal to 0. Yes, that's correct. No? F1 times 3.9 minus F2 times 2.5 is equal to 0. Now, this is an equation with two unknowns. Di ba? So meron tayong isang equation at dalawang unknown, F1 and F2. Now, this is equation number 2. And if we make summation of vertical forces as equation number 1, ito, yung negative F1 plus F2 minus W is equal to 0, or you can translate this as negative F1 plus F2 minus 530 is equal to 0. Now, this summation of vertical forces equation and the summation of torque equation are two equations with two unknowns. Diba? So therefore, you can solve this using algebra by elimination or by substitution. Can you do that? Parehas lang silang variable. Kumbaga, parehas silang may F1 tsaka parehas silang may F2. So parang x plus y yan. Parang x plus y equals 5. Yung isa naman, x plus y equals negative 2. So parang ganun. Two equations, two unknowns, you can solve the problem. So, kung ginawa ninyong fulcrum, yung woman, dalawa yung unknown, yung F1 and F2, parehas nung summation of vertical forces. So therefore, using your knowledge in algebra, solve these two equations simultaneously. Okay? By substitution or by elimination. Can you do that? And give me the values of F1 and F2. Dapat parehas sa mga nakuha natin. Sige nga, itry nyo nga. So equation number 1 ninyo will be what? Negative F1 plus F2 equals 530. Ilipat nyo na yung weight para maging positive. Okay? So dito naman sa isa, F1 times 3.9 minus F2 times 2.5 is equal to 0. Okay? Algebra lang yan. Apply your stock knowledge in algebra. Anybody? Anong lumabas na F1 and F2? Nakalimutan na ba yung algebra? Hmm? Nakalimutan na. You can use substitution. Halimbawa, sa torque equation, anong pwedeng maging substitution method nyo? F1 is equal to what? Express F1 in terms of F2. So if you solve for F1, F1 will be equal to what? 2.5 F2 divided by 3.9. Right? Ang F1 ninyo is equal to 2.5 F2 all over 3.9. So substitute that back doon sa vertical equation. So negative F1, so magiging negative 2.5 F2 all over 3.9 plus F2 equals 530. Okay? O tanggalin nyo yung 3.9 na denominator, you multiply both sides by 3.9. So that means to say every term must be multiplied with 3.9. So nakikita nyo, wala ng F1, di ba? Kasi yung F1, in-express natin na in terms of F2. So ang masosolve nyo dyan is F2. Kung ayaw nyo naman, you express F2 in terms of F1. So meron naman kayong choice, no? Whether you solve for F1 at tapos express in terms of F2, substitute sa vertical equation, and then give me the results and compare your results with the previous results we obtained. Schedule ka, hindi ka tama. Hindi kang buwang klase. Sarang blend, sarang 50-50, sarang... So may gusto pang ganun din po ito na 2 weeks na yan si Block A. Next week naman, so Block A, maparehas. Block B naman ang 2.
Ano kaya, sir? At some point, mas maganda ang puro sa amin na lang yan.
Ang DPC, so may, ako na may ng question, si Sir na araw, may 3 hours na straight, paano ka ito dito? Pero tingnan, the other level ang data.
One po lang, sir.
70 to 100% face to face.
Hindi, sir, mag-face-to-face pa rin.
100%. Problema rooms.
Kaya, sir. Ha? Pero hindi nakaka-full-page.
Paano na ito? Palinigan sa mga EL. Sabihan ta na si ano, DP ito na. Si Sani, so ano pa? Diyan ito. This is mga susunod. Diyan. Yan sa drawer ni Sir.
Marami, sir.
So, Sir Buro, ano pa daw PJ? Yung Sir? Hindi pati kitang mga ano dyan. Dipisil pati ang buksan, ta mga steel door baga.
Sir, pwede pa mo yung RS. Kung mag-press ko dyan.
Bahala na kung si Sir magkauro lang ng dipis.
Ayun, sir. Wala akong tinasir na choice.
Yan na lang. Tapos so, ito baga. So, sabihin ta kay Ma'am O, haliw na itong mga gamit nila doon.
Okay, sir. Si sir magamit ka rin.
So, video ay ano,
Yes, sir. Whiteboard siya dyan, sir.
whiteboard dyan, wala kitang ano.
Wala ako, eh.
Baka sa mga chok dyan sa supply, paraso na. 2 taon na pala. Baka dahil nagsusulat ito.
Finals na, sir.
Ayan. Okay, nakuha niyo ba yung ano? Using algebra? Sinong nakakuha? Did you get it?
Equal lang po, sir.
Ha?
The same lang po.
Sinusolve niyo pa?
Yes po, sir.
Okay, can you see this? Papakita ko. Dapat at least ganito yung ginawa nyo. Okay? Di ba meron tayong negative F1 plus F2 equals 530, di ba? Yun yung summation galing sa summation of vertical. Pangalawa, yung sa torque. Di ba? Ito, yung sa torque. Okay? Tapos, ayun sa torque, sinubstitute natin, sinolve natin yung F1 in terms of F2. Galing sa torque equation. Tapos, yung F1, in-express natin in terms of F2, sinubstitute natin doon yung F1. Yung F1 baga in terms of F2, kaya pag sinubstitute doon, yung F1 lahat na in terms of F2. So lahat na siya in terms of F2, you can now solve for F2 kasi isa na lang yung variable. Correct? Nakita nyo? Hindi.
Nakikita po, sir.
Can you follow? Nasundan nyo ba yung sinolve ko? Nag-substitute ako. Okay? In-express ko yung F1 in terms of F2. Now remember, may negative baga doon, negative F1. Kaya dapat magiging negative din yon. Okay? Tapos, in-eliminate ko yung denominator. Tinanggal ko yung 3.9. So, paano yun matatanggal? I multiplied both sides by 3.9. Every term. Okay? Para matanggal lang yung denominator. Follow? Nakuha nyo o hindi?
Ako po, sir.
What about the others?
Nakuha
Now,
po.
hindi... Nakuha nyo?
Yes po.
Now, the other solution to that is, kung ayaw nyo yung F1 in terms of F2, yung F2 gawin nyo in terms of F1. Okay? Such that, ang papalitan nyo naman doon, yung F2, doon yung isa-substitute sa F2, yung in terms of F1. Ang masosolve nyo naman dyan is F1. Okay? F1 naman yung masosolve nyo doon. Okay, so can you understand the process? Nakukuha nyo ba? Okay, let's move to fighting a fire. Okay, we have this one. In this figure, may tumatay yung fireman, no? Ito yung wall, ito yung ladder where the fireman stands, and this is the ground. The ladder is placed 50 degrees with respect to the ground. Okay? Okay, so in this figure, an 8-meter ladder. Okay, so the length of the ladder is 8 meters. Of weight, W is equal to 355 newtons, leans against a smooth vertical wall. Smooth vertical wall. So that means to say, kapag smooth, friction is neglected. Walang friction between the ladder and the wall. Okay? So the weight of the ladder is 355 newtons. Where do you think is the weight acting? Saan dyan yung weight? Saan sa tingin nyo concentrated yung weight? Assuming that the ladder is uniform. Parehas yung length, pare-parehas ng thickness, yung steps, and every material is uniform. So when the material is uniform, the weight is concentrated where? Kung ang bigat ng ladder is 355. Saang point ng ladder nag-a-act yung 355? Where do you think? Anybody?
Gitna po, sir.
Yes, at the middle of the length, no? So, hatiin nyo yung ladder at 4 meters, no? So, doon nakakoncentrate yung weight, and the weight is always acting vertically downward. Kahit pa yan naka-incline, ang weight is always vertically downward. Okay? So, at 4 meter length from either end, nandun yung weight. Okay? So the term smooth means that the wall can exert only a normal force directed perpendicular to the wall. So ito yung force niya is perpendicular, yung wall, papunta doon, to the left. Otherwise, yung ladder is bababa kung walang force offered by the wall. Okay? So it cannot exert a frictional force. Okay, kapag smooth. Now, a firefighter whose weight is 875 newtons. So, mas mabigat yung firefighter kaysa sa ladder, no? 875 yung weight, yung bigat nitong firefighter. So, therefore, kung saan siya nakatayo, nandun din yung weight concentrated. So, at this point, nandito yung weight vertically downward. Okay? And the firefighter stands 6.3 meters up from the bottom of the ladder. So, where is that 6.3? From the ground, kung saan nandun yung ladder, ito, no? Then, you measure 6.3 along the ladder. That is where the firefighter stands. Okay? So, kung saan nandun yung paa ng firefighter, yun yung 6.3 meter mula dito sa ground, sa foot ng ladder. Okay? Hanggang dun sa feet ng firefighter. So that is 6.3. So therefore is, or if this is 6.3, alam na natin ang length mula dito sa feet ng firefighter up to the top of the ladder. Di ba? You just subtract 6.3 from 8 meters. That is the remaining length. Okay? Now assume that the ladder's weight acts as the ladder's center. Okay? So yung ladder's weight acts at the ladder center. So ito na yung kaninang tinanong ko, di ba? When everything else is uniform, okay, the weight of the ladder is always at the center of its length. No? And neglecting the hose weight, okay, yung weight ng hose, we neglect that. So meaning to say, we ignore that. Okay? So hindi kasama yung weight ng hose. Find the forces that the wall and the ground exert on the ladder. Okay, so we need to draw the free body diagram. Ito yung kanyang free body diagram. Okay? Itong force P, horizontally to the left, is the force exerted by the wall, no, on the ladder. Kasi smooth siya, so horizontal yung force niya kasi walang friction. Now, yung sa ground, okay, these are the components. Okay, so this is the X component of the force of the ground, and this is the Y component. So ang talagang force niya ay ito, nasa ladder, papunta dito. If we want to get that force, we use Pythagorean theorem. Di ba? So ito na yung free body diagram. Itong W sub L is the weight of the ladder. 4 meters. Nakita nyo? 4 meters siya. Okay? And ito yung weight ng firefighter. 2.3 plus 4, ito na yung 6.3. Okay? Ito, if you add. Okay? So our objective is to find the force P and the GY and the GX. Okay? O, dito sa letter C. The point on the ground where the foot of the ladder is, that is made the axis of rotation. Okay? So kung itong gagawin nating axis of rotation, dalawang force kagad ang nawala. Yung GY and GX. Although kailangan sila, pero wala silang torque because both pass through the axis. Diba? Sabi ko kanina, whenever the force passes through the pivot point or through the axis of rotation, zero torque. So, kung gagawin nating axis of rotation to, walang torque si GY and si GX. At ang may torque lang ay si WL WF, and CP. Okay? So we determine their lever arms. So we extend the WL line of action. So ito yung kanyang line of action. Ang kanyang lever arm is ito, L sub L. Itong dotted line. So yan ang kanyang lever arm because that is perpendicular to the line of action. Now, sa WF naman, asan ang kanyang lever arm? Okay, we extend the lever arm downward. And then, ito namang axis of rotation, we extend this hanggang dito sa intersection. So itong point na to, up to that point is the lever arm of WF and that is L sub F. Get it? Nakukuha niyo ba? Because it is the perpendicular distance from the line of action. What about the force P? Saan ang kanyang lever arm? Okay, we extend the force up to here and then we drop a perpendicular line, itong mahabang dotted line brown, intersecting the axis of rotation. So this dotted line, itong red or brown, is perpendicular to the axis of the force P. So ito ang kanyang lever arm, L sub P. Okay? So having obtained all the lever arms, we can now make summation of torque equation by bearing in mind that counterclockwise torques are positive and clockwise torques are negative. As you can see, ang force P ang counter. Diba? So we can start with force P kasi siya yung positive. So P times LP, itong WL and WF both cause clockwise torque, diba? So pares sila negative. So kung bubuuin na natin, ang torque equation is P times LP minus WL times L sub L minus WF times L sub F equal to 0. Okay? So our challenge now is to find every lever arm. No? So, paano natin kukunin itong mga lever arm? Itong L sub L, paano natin kukunin? Given this right triangle, how do we find L sub L? Given that the angle of the ladder with respect to the horizontal is 50 degrees at alam din natin itong hypotenuse nitong maliit na right triangle. Di ba? This is 4 meters from the drawing here on the left. So this is 50 degrees. L sub L is 4 cosine 50. Correct? So kuha na natin yung L sub L. 4 cosine 50. What about L sub F? Okay, L sub F, what triangle are we going to consider? We consider this bigger right triangle. Ito. Okay? So we consider this. And this one is the hypotenuse from axis up to the point of WF. Okay? So ano yung WF? Ito, nakita niyo naman to, di ba? So what is that length? 4 plus 2.3, that is the 6.3. The angle remains the same, 50 degrees. So therefore, L sub F is equal to what? 6.3 cosine of 50. Okay? 6.3 cosine 50. Any questions so far? Yung yung mga weight nila, walang problema. Those are given, right? Di ba yung weight ng ladder tsaka weight ng fireman given? Now, what about yung LP? Paano kukunin? Okay, LP, you consider this right triangle. Okay? Or you consider this. Now, if this is 50, this must also be 50. Di ba? Ito. Okay? Alternate interior angles are congruent. Ito, 50 degrees. Ito naman, 50. Now, kung ayaw nyong gawing 50 to, ito ang gawin yung angle. What is this? Equal to, ito. The angle of the ladder with respect to the vertical is equal to what?
40 degrees.
40 degrees po.
Okay, 40 degrees. So, yung 40 degrees, pwede nyo rin itong gamitin. Okay? So, kung gagamitin nyo yung 40, yung hypotenuse is the length of the ladder, which is 8 meters. So, yung LP is adjacent to 40. So yung LP is equal to 8 cosine 40. Correct? 8 cosine of 40. Now, kung gusto niyo namang gamitin yung 50 degrees dito sa taas, pwede rin. Opposite yung LP. So LP is equal to 8 sine 50. Parehas lang yun. Okay? 8 sine 50 is equal to LP or 8 cosine 40 is equal to LP. Parehas lang yun. Okay? So having obtained all the, what do you call that? Lever arms, di ba? Yung kanina, P times LP minus WL times L sub L minus WF times L sub F, makukuha nyo na dyan yung P, yung force P. Okay? So ito yung summation. Okay? So you can also sum up horizontal forces. Pwede rin dito. And summation of vertical forces. Ito, summation of X. Anong summation of X? Gx minus P is equal to 0. Okay, ito. Summation of Y. Gy minus WL minus WF is equal to 0. Ayan. Okay? So, pwede rin yan. Para makuha nyo yung Gy. Pero yung Gx is equal to P. Hindi nyo makukuha yan. Kasi dalawang unknown. So, ang torque equation ang magsosolve niyan. Okay? So, pwede rin dito, you can start with summation of vertical and horizontal forces, pero makukuha nyo lang dyan si Gy. Okay? Pagdating kay Gx, hindi nyo mako-compute si Gx tsaka si P kasi parehas sila unknown. So, anong makakasolve niyan? Dun sa summation of torque kanina. Kung magre-reference tayo dito sa axis, ang equation natin is P times LP. Merong LP, di ba? Galing dun sa right triangle, yung 8 cosine ng 40 or 8 sine ng 50. Meron tayong value niyan. So, P lang yung unknown. So, P times LP minus WL, meron tayong WL. 355. Ito, given. Okay? So, minus WL times L sub L. Alam natin yung L sub L, di ba? 4 cosine ng 50. So, meron yan. Minus WF, meron tayong WF. Weight of the fireman, 875. LF, meron tayo. And that is 8 cosine ng 50. Okay? So, equal to 0. So, in effect, P lang yung unknown. So, you can solve for P. Okay? You can solve for P. And after solving for P, i-substitute nyo na dito sa summation of X. Kasi yung Gx is equal to P. Diba? I-transpose nyo dito yung P sa right. Gx is equal to P. So Gx and P are equal in magnitude. Okay, so una nyo makukuha yung P galing doon sa torque equation. P times LP minus WL times L sub L minus WF times L sub F. You can solve for P. And then, yung Gx, Gy, kanina nakuha na sa vertical. Okay? And yung Gx is just equal to P. I-transpose yung P dito. May value na kayo ng P from the torque equation. So whatever is the value of P, then that is also the value of Gx. Okay? So everything now is being solved. Okay? Ito yung torque equation, yung kanina. Okay? P times LP minus WL times L sub L minus WF times L sub F. Okay? So ito yung sinasabi ko kanina. Makukuha nyo yung P. Kasi everything else are already found, no? Yung dalawang weight, given. So ang problema lang yung tatlong lever arm. Pero na-compute na baga natin yung lever arm, di ba? Using the 3 right triangles and the trigonometric function. Okay? So pag nakuha nyo yan yung P, yun na rin yung Gx. Kasi nga, Gx minus P is equal to 0 or Gx is equal to P. Okay? Okay, ito naman, yung muscle. Okay. Yung bodybuilder, may dumbbell. Okay, ito. May WD na weight. His arm is horizontal and weighs W sub A, yung kanyang arm. And the weight is 31 newtons. The deltoid muscle is assumed to be the only muscle acting and is attached to the arm as shown. Asan yung deltoid? Ito, no? Okay, the red one. So the deltoid muscle is assumed to be the only muscle acting and is attached to the arm. Now, the maximum force M that the deltoid muscle can supply has a magnitude of 1,840 newtons. Okay, so ito yung deltoid muscle. So this is the free body diagram. What is the weight of the heaviest dumbbell that can be held? And what are the horizontal and vertical force components, Sx and Sy? The shoulder joint applies to the left end of the arm. So ito yung shoulder joint. Okay, and that is the point here. Ito yung end. Ito. Etong M is the deltoid muscle. So that is inclined force, yung ano, no? Yung effect ng deltoid muscle, tingnan nyo, it is an inclined force. The dumbbell, WD, vertically down kasi weight. Also, the weight of the arm is vertically down. Okay? Yung weight of the arm, okay, so the weight of the arm is, ito yung total length ng arm, 0.62. And the weight of the arm is 0.28, no, meter from the shoulder joint. So maybe, yung weight, nakita nyo, hindi siya sa center ng arm. Medyo malapit siya to the left, malapit sa joint. Why? Tingnan nyo yung structure ng arm ng tao. Yung malapit sa hand, manipis lang, di ba? Habang papunta ka dun sa shoulder, pakapal ng pakapalang muscle. Okay? So therefore, if this is the total length of the arm, hindi natin masasabi na kapag hinati natin yung arm, ay nandun yung kanyang center of gravity. Okay? Now, para mabalance ito, yung point, yung balance point, the fulcrum must be a little bit towards the left. So itong weight ng arm is concentrated more, medyo nandito sa left. Okay? Kasi to compensate for ito, kasi manipis dito yung muscle eh. 'Di ba? So therefore, umusog ng konti yung kanyang centroid or center of gravity. So makikita nyo, kung hahatiin nyo yung 0.62, kung balance ang arm, pare-parehas ang muscle, yung thickness, kalahati ng 0.62, that would be 0.31. Diba? 0.31. Now, since hindi nga siya balance, kasi nga, yung mas malapit sa kamay ay maliit na muscle, at yung papunta sa shoulder ay pakapal ng pakapal yung muscle, so yung weight nakakoncentrate more on papunta doon sa shoulder. So nakikita nyo, nasa 0.28. Okay? Yung weight of the arm. Now, of course, that is not given in the problem, pero binigay sa figure. Okay? So binigay yan, so do not question me kung bakit naging 0.28. So pinaliwanag ko na hindi siya sa kalahati ng 0.62, but a little bit closer to the shoulder. Kasi nga, yung muscle dito ay malalaki. So dapat, yung centroid ng arm is concentrated, malapit din doon. Para mabalance. Kumbaga, itong 0.28, that is the point na kapag tinukod mo dyan yung arm, ay balance siya horizontally. Okay? So these are the forces acting on the arm. The two weights, weight of the arm itself, the weight of the dumbbell, both vertically down. Ito yung muscle of the deltoid is inclined to the left, upward. And S of X and S of Y are the forces. Okay? Horizontal and vertical components, okay, of the shoulder joint. Okay? Eto. Yung parang yung kanina, yung GX tsaka GY doon sa sa ladder, di ba? Parang ganito siya. Okay? So ganun din sa shoulder. Okay? So ito na ngayon yung kanilang lever arm. So makikita nyo yung dalawang weight, walang problema sa lever arm. Makikita natin 0.28 at 0.62. Ang problem natin is kapag ang force ay naka-inclined, what will be the lever arm? So nakita nyo yung lever arm ng deltoid muscle is ito lang, maliit lang. Okay? So you have to compute that, or meron baga tayong ginawa kanina? What did we do with the force, yung naka-incline? Anong ginawa natin para halimbawa, ito baga 0.15, di ba? Yung point ng deltoid muscle up to the shoulder joint is 0.15. Di ba kanina, halimbawa, gusto kong gamitin ang 0.15 as the lever arm. Anong gagawin ko sa force? I need to what? Para magamit yung 0.15 na lever arm, anong gagawin mo sa force M? We what?
Kunin, sir, yung vertical component.
Yes, we resolve the force into components. At tingnan natin kung ano sa dalawang component ang naka-vertical dun sa lever arm. It's always in this case, yung vertical. Tapos yung horizontal niya passes through the axis, kung itong magiging axis natin. Okay? So yung vertical component ng M and 0.15 yung lever arm. Okay? So given naman yung deltoid muscle, ito baga 1,840 newtons, at given naman yung kanyang inclination na 13 degrees, so mariresolve natin siya. Di ba? So yung vertical component niya is M sine 13. Sine because opposite yung vertical component. Di ba? So M sine 13 times 0.15, yun yung kanyang torque. Okay? So, summation, kung ito yung axis of rotation natin, matatanggal na si SX and SY because dumaan sila ng axis. So, ang may torque na lang is the deltoid muscle and the two weights. Okay? So, ano yung equation natin? Summation. Okay, pwede rin tayong mag-start ng vertical forces and horizontal. So halimbawa, start tayo ng summation of horizontal, Fx, equal to 0. So ano yung summation ng horizontal? Sx positive, kasi to the right, di ba? So Sx minus what? M cosine 13, di ba? Kasi yung x component ng M is to the left, di ba? So silang dalawa lang naman, wala nang iba. So Sx minus M cosine 13 is equal to 0. Ito siya, equation A. Nakuha nyo ba kung bakit ganito? Nagsa-sum up tayo ng horizontal forces. Dalawa lang naman ang horizontal, si Sx at yung x component ni M. Nagkataon na yung x component ni M is papunta sa left, kaya negative. So Sx towards right is positive. So Sx minus M cosine 13 equal to 0. Okay? So i-substitute nyo na lang sa M yung 1,840, makukuha nyo na yung Sx. S of x is equal to M or 1,840 cosine 13. Meron na kayong value kagad ng S sub x. Okay? Ito. 1,790. Pero sa convention natin, hindi yan ang eksakto, di ba? Up to 2 decimal place tayo. Now, kung magsasum up naman tayo ng vertical forces, ano-ano yung may vertical? Itong SY upward. Itong dalawang weight downward, negative. Ano pa yung isang upward? Yung vertical ni M. M sine 13. So dalawang positive natin, SY plus M sine 13 minus WA minus WD equal to 0. Okay, ito. SY plus M sine 13 minus W sub A minus W sub D is equal to 0. Now, itong equation B, given ba yung weight ng ano? Yes. Weight ng arm lang ang given. So itong equation B, we cannot solve. Why? Because Fy is unknown and weight of the dumbbell is also unknown. Kahit given na yung weight ng arm at yung M ay given, dalawa pa rin ang unknown dito, S sub Y and WD. So we cannot solve, di ba? Because we have one equation and yet there are two unknowns. So, where are we going to get the other equation? Doon na papasok yung torque equation. Okay? Ito na yung sinabi ko kanina na magsasum up tayo ng torque. Parang yung torque kanina sa ladder, ganun din ang gagawin natin. Okay? So, if this is the axis of rotation, kung nasaan dumaan si SX and SY, wala nang torque si SX and SY. Tanggalin nyo na yan. Kasi dumaan sila ng axis of rotation. Eliminated na sila sa torque equation. So, tatlo na lang ang magpa-participate sa torque. Si M, si WA, at si WD. Okay? So, we can start with, okay, ang sabi ko baga, resolve M into components. So, si vertical component lang niya ang may torque at ang kanyang lever arm 0.15. Yung X component ni M passes through the axis. Wala rin siyang torque. Okay? So, tatlo lang ang may torque. Vertical component ni M, si WA at si WD. So, formulate the torque equation by bearing in mind that counterclockwise torques are positive and clockwise torques are negative. So, sino dito sa tatlo ang merong counterclockwise? Remember, upward itong si M. Ito yung kanyang vertical component. Okay? So, this is M sine 13 or 1,840 times sine 13. Meron kayong value nun. Okay? So, M sine 13 times 0.15, counterclockwise ba gayon? So, that is positive. Di ba? M sine 13 times 0.15 minus WA times L sub A. Yung L sub A is 0.28. WA is given, 31 newtons. Given yan. Weight ng arm. So, walang problema, di ba? Minus 31 times 0.28 minus WD times 0.62. Okay? WD is unknown kasi isa yun sa pinapahanap. What is the weight of the dumbbell? Diba? So minus WD times LD. Yung LD given, ayun, 0.62. Diba? So everything else is given. One equation, one unknown in weight of the dumbbell. You can solve for the weight of the dumbbell. Right? So I repeat, 1,840 sine 13 times 0.15 minus 31 times 0.28 minus WD times 0.62 equal to 0. Give me the value of the weight of the dumbbell. That is the only unknown there. Okay? Oh, ito na yung weight of the dumbbell. No? Did you get my procedure? Nakuha nyo ba? O hindi? Okay, did you get the... Nakuha nyo na yung WD. What is the weight of the dumbbell using the torque equation? 1,840 sine 13 times 0.15 minus 31 times 0.28 minus WD times 0.62 is equal to 0. Yes. May papasok pa lang. Nakuha nyo ba yung WD? What's the weight of the dumbbell? I-divide nyo lang naman ng 0.62, no? Yung 1,840 sine 13 times 0.15 minus 31 times 0.28 all over 0.62. What is WD? So after getting the weight of the dumbbell, you substitute dun sa it's either dun sa equation B, summation of vertical forces. Para makuha naman yung SY. Okay, so I leave that to you. Now, sa torque pala, like this one, makikita nyo may nag-negative yung SY. So that means to say, the magnitude is correct, but ang ibig sabihin ng SY is yung direction, no? Ibig sabihin, itong inassume dito na SY is upward is not correct, but it is downward, no? Downward yung SY. Yun lang naman ang ibig sabihin ng S sub 1. Kapag nag-negative kayo sa mga variables, the magnitude is correct except that yung direction ng free body diagram, you have to reverse that. Okay? So ibig sabihin nitong SY dito, negative 294. Yung SY is 294 newtons and yet ibig sabihin nito is yung SY ay hindi dapat pataas kundi pababa. Okay? So that is S sub 1. Okay? Okay, so for your homework, kasi wala pa tayong portfolio ilalagay, no? Solve 5 problems regarding rotational dynamics. Okay? At yun yung ilagay sa portfolio as well as the finals. Okay? So we will be having finals on Friday. Okay? So ito lang, rotation. Ano pa yung na-discuss natin aside from rotational dynamics? Meron pa ba akong na-discuss? So look for 5 problems about rotational dynamics and ano yung diniscuss ko last meeting? So look for 5 problems about rotational dynamics and then solve. So I want the problem after the problem given, required, drawing, and then solution. Okay? And part of the solution will be the free body diagram. Dito na yung mga completion form. So, i-check ko na lang. Yung mga ganito, submit na kayo? Completion form? Sige, i-check ko na lang. Message na lang. Yes? May question?
Meron po, sir.
Okay, what time sa Friday kayo available? Ay, may power interruption ba?
Opo, sir.
Where?
6 to 6.
Friday? Anong oras?
6 a.m. to 6 p.m. po, sir. Bitano,
6
tapos
to-
Washington Substation.
Bitano
1
and
to 4.
Washington.
Opo.
Siya,
Oo, sir. Oo, sir.
anong substation ng SEM?
Iyo, sir. Brand out ligdi, sir.
Bitano and Washington sa Friday.
Oo, iyo, sir. Buo.
Kasabay kita.
Buo, sir. Kaya, di ba ako, sir, nag-exam na Friday? Thursday ako, sir, gabos.
Wala nang magde-defense. Okay, when do you like to have the exam? I'm not available on Saturday and Sunday kasi may klase din ako sa doctoral. So I cannot meet you on Saturday. So when do you like to have the exam? Thursday or Monday next week? Okay lang sa inyo even if tapos na yung klase? Okay lang? Would it be all right? Okay lang sa inyo Monday? You want Monday? Okay,
Yun lang po,
so
sir.
para makapag-prepare kayo, no? So
Yes po.
ang content lang ng portfolio will be basta yung last na na-discuss ko, gawa din kayo ng 5 problem doon. So 5 problem doon yung last plus 5 problem about yung diniscuss ko ngayon, yung rotational dynamics, more on about torques. Okay? And then sige, i-exam ko na lang sa inyo torque alone. Okay? Torque na lang. Pero ang content ng portfolio will be yung 5 problems about the previous topic we discussed plus 5 problems about rotational dynamics, and these are more about torques. So 10 na, di ba? 10 yung laman ng portfolio plus yung final exam sa Monday. That will be on top, nasa ibaba ng portfolio. And submission will also be next week, within that week, hanggang Friday lang. Okay? Di ba mag-exam tayo ng Monday? So magsasubmit kayo ng portfolio until Friday. Okay?
Question lang
Clear?
po, sir. Clarification lang po. Clarification lang po, sir.
O ano yung
Yung kanya-kanya po, sir, yung problem. Kami po magpipili ng problem po namin.
yes, kayo magpipili. If possible, walang parehas na problem, no? And then write the references kung saan nyo pina yung problem. Okay?
Sige po, sir.
Okay, so I think that would be fair enough kasi I cannot give you more problems kasi bukas is last day na ng ano, no? So I'm sorry that I haven't met you for quite several times. So siguro sa susunod I won't be siguro I'll give these mga subjects ganito sa mga ibang faculty kasi I cannot have time, no, being the head of the department. Meeting lang halos kami ng meeting, no, because of right now pinag-iisipan if 100% face-to-face. Yun ang challenge, no? Pero one thing for sure, if we stay to be or to remain, if we are to remain at level 1, ang face-to-face will be 70% up to 100% of the total number of students ay magfe-face-to-face. 70 up to 100%. So most probably 100%. Okay? Level 1 lang yon. Ngayon, pag tumataas yung cases, nagle-level 2, level 3, blended learning. Okay? So meaning to say, 50-50 na yung klase. Kalahati ng class will be attending the face-to-face while the other half will have to do something sa bahay. So kalahati na face-to-face, kalahati merong ginagawa sa bahay. Tapos, reverse naman, the following meeting, yung nasa bahay, sila naman ang mag-face-to-face at yung pumasok ng face-to-face, yun naman ang sa bahay. So ganun yung level 2. Hinahati yung klase.
For lab subjects po yan, sir, or for all na po.
Yes, sa lahat ng subjects. Pag nag-level 2, pag hindi tayo, pag tumaas yung case. Okay? Tapos pag nag-level 4, nag-lockdown, ayun, balik tayo sa online class. Wala na munang face-to-face. Pero definitely sana hindi. Okay? Para makapag face-to-face naman kayo. Okay? Kasi ang hirap din. Ako nahirapan. Alam ko nahirapan din kayo, pero mas mahirap yung ganito. Ako nahirapan ako magturo ng online. I cannot very well or I do not know well whether you understand me or not. No? Kasi iba yung ini-explain ko lang kaysa sa tinuturo talaga sa board. Okay? So
Okay ko lang po, sir, ulit.
Mm-hmm.
Ang ipapasa lang po namin, sir, for portfolio sa susunod na, sa next week na Friday. Yung 10 problems, sir. Yung 5 sa previous lessons, plus 5
Nagsubmit
sir,
ba kayo sa akin
tapos yung
ano?
final.
Nagsubmit ba kayo sa akin nung sa midterm? Hindi.
Wala
Hindi
po,
pa?
sir,
Wala
naalala.
po, sir.
Ha?
Hindi po, sir.
Hindi po.
Ay, sama nyo na. Hindi pala kayo nag-submit. Isabay nyo na yung sa midterm.
Ano
Yung
yun, sir?
lahat na
Isang
na-discuss.
folder lang po.
Ha? Oo, sa
Isang folder
folder.
po.
Di ba konti lang naman
Yung
yata
exam
binigay ko
lang po, sir, ang
konti lang naman yata binigay
inaano.
ko sa inyo, di ba?
Opo, tape problems lang po, sir.
Oo, isabay nyo na yun. Okay? So yung sa midterm, kung ano man yung sa midterm na naibigay ko, yun lang ang isama nyo. Plus yung na-discuss ko last week, 5 problems, plus 5 problems yung rotational dynamics, yung sa mga torque, itong diniscuss natin ngayon. Pero yung magiging final exam ko lang will be about torque. Okay?
Yung mapa-courier po, sir.
Ay, of course, no,
resibo
naka-folder.
na po.
Of
Resibo
course,
na po.
naka-folder, long band paper, blue ball pen, and then one direction lang, pababa, top to bottom. Okay?
Sir, sarang folder na lang po si midterm sa finals.
Yes, isa na lang.
Sige po.
Yung
And then
mapa-courier
make,
po, sir.
yes, folder, tapos naka-fasten sa taas. Make your penmanship readable. Huwag niyo akong paggagamitin ng magnifying glass. Ha? So I know tapos na kayo ng drawing, ng lettering. So apply your technical drawing lettering. Ha? Okay? So submission natin is Friday, next week. And then isubmit na lang dito sa SENG kung malapit lang. No? If not, then you have to mail it through courier. Okay? So marami pa ring updates ang malalaman nyo kapag after na nag-meet na yung mga faculty regarding the face-to-face classes. Okay? So just in case lang naman, no? So pag mag-face-to-face, of course, you have to be in school uniform. Okay? You have to be in your school uniform. Okay? What else? Okay, no, may question pa?
Yung mapa-courier po, sir, yung send lang po ng receipt po ulit sa messenger.
Yung magko-courier, if possible, you send it before Friday para o kahit Friday, no? Kahit Friday morning ipadala nyo para by the following week, siguro baka Monday nandito na yun.
Masanda lang po, sir, ng resibo po.
Yes, no? I-send nyo sa akin yung receipt. Okay? Address to me dito sa Care of College of Engineering, ME Department. Okay, what time will be the exam? Sa Monday. Afternoon, gusto nyo? Afternoon na lang kasi pag morning baka i-exam ko yung sa calculus. Okay, mga 2 o'clock in the afternoon yung exam. Okay.
Ilang oras po,
will-
sir, yung exam, sir?
Siguro 2 to 4. Okay? So inform the 3 blocks.
Ilang items po yan, sir?
Ilan ba yun? 2 hours? Siguro mga 4 items lang. Okay? 4 problems. Okay? So, next week, next Monday ang exam. Okay? And yung portfolio will also be next week, Friday. Okay? Di ba Monday next week ang exam? Then yung week na yon, yung Friday, yun yung deadline for the portfolio. Okay? Any other questions?